So here in this video we are going to discuss about linear independence and also linear dependence. So what is the meaning of linear independence? So let me give the definition first. Linear independence. So here we have a set of vector v1, v2, vp, okay, in the Rn is set to be linearly independent if the vector equation this one is equal to 0. Okay, so this vector equation has only the trivial solution. So what is a trivial solution? A trivial solution here means x1 equal to 0, x2 equal to 0. So what I will select this one. So x1 equal to x2 equal to equal to xp equal to 0. So all x equal to 0. So this is the meaning of trivial solution. So then how about linear dependence? So let me give definition. Okay, it's fine. I will write the definition in two different kinds, right? Okay, so here linear dependence. Okay, so what is the linear dependence? So the set of vector, okay, the set of vectors, okay, so we have a set of vector v1 until vs, okay, this is set to be linearly dependent okay if their axis with okay if there's axis with k1 until ks is not are not equal to 0, are not all equal to 0 and such to 0, okay, such that this equation holds. Okay, so now I will give some examples. Okay, first example here. Example 1. So I have a vector of v1 equal to 1, 3, 5, okay, and also v2 is equal to 2, 5, 9, and then v3 is equal to minus 3, 9, 3. So the question here, determine if v1, v2, and v3 is linearly independent. Okay, so first of all, we need to solve the equation. So solution. Okay, here we have x1 times the factor v1, okay, and 1, 3, 5, and plus x2 times 2, 5, 9, and plus x3 times, okay, sorry, this is times, right, okay, times minus 3, okay, this is minus 3, 9, 3, okay, and this is equal to 0, 0, 0, and then we have linear system, x1 plus 2x2 plus, okay, this is minus 3x equal to 0, and then 3x1 plus 5x2 plus 9, okay, this is x3 equal to 0, and then we have 5x1 plus 9x2 plus 3x3 equal to 0. So the next step, we need to solve the problem. So how to solve the problem? So we can use excellent row reduction. So first of all, we need to write into matrix. Okay, so here we have 1, 2, minus 3, 0, and this is 3, 5, 9, 0, and then we have, okay, what? I need a big matrix here. Okay, and then we have 5, 9, 3, 5, 9, 3 equal to 0. So using row reduction, we have here, okay, so R2, this is R2 minus 3 R1, and this is, we have R3, this is equal to R3 minus 5 R1. So we have still 1, 2, minus 3, 0, and here we have 0, minus 1, 18, and 0, and here we have 0, minus 1, 18, and 0. Okay, since we has since we have row 2 and row 3 equal, so we can eliminate the row 3. So our matrix become 1, 2, minus 3, 0, 0, minus 1, 18, 0, 0, 0, 0, 0. Okay, So here we can see that x3 is a free variable. So which means, for example, I put x3 is equal to like, what is it? Okay, x3 is like s. So we can put any real number here. Okay, and then we have x2, right? x2 is equal to oh sorry, okay, so in here we have, right, I think I will write down. Okay, so here we have minus x2 plus 18 x3 equal to 0. So here we have x2 equal to 18 x3, because we already write x3 as equal to s. So we have, this is 18s, and then we go to the first equation. We have x1 plus 2x2 minus 3x3 equal to 0. And then here we have x1 plus, so we have 18 times 2, we have 36 as, right. Okay, this is 36s. Okay, and then we have minus 3s equal to 0. So x1 equal to minus 33s. So this vector is a linear dependent set. It's not linear independent because has no trivial solution. So since no trivial solution, so v1, v2 and v3 is linearly independent. Okay, then let's move to the second example. Okay, so here we have example 2. Okay, so for example 2 here, we have u1, okay, u1 equal to 1, and here we have u2 equal to 2. Okay, so the question here, determine if u1, u2 is linearly dependent. Okay, so solution. Solution here, first of all we need to find the solution of this equation. So we have k1 u1 plus k2 u2, this is equal to 0, and this one we have k1 to 1 plus k2 for 2 equal to 0. So we have 2k1 plus 4k2 equal to 0. And then we have k1 plus k2. This is equal to 0. Okay, so we can eliminate maybe. So this is this is times by 2 maybe, right? Okay, or that we can set here k1, this is equal to minus k2, right? Okay, so we have k1. So for example, I said k2 is equal to minus t, right? T, so this is become minus t. Okay, so if we have 2k1 is equal to like 4k2. Okay, so wait, I think it's better for us to use eliminate, right? So so here we can multiply, right? This is by 1, this is by 2, right? Okay, so we have 2k1 plus 4k2 equal to 0. And here we have 2k1 plus 2k2 equal to 0. And this is, we can find minus. So this is 2k2 equal to 0. So which means we have k2 equal to 0. Okay, so we also have k1 is equal to 0. So we can conclude that the vector u1 and also u2 is linearly independent. Okay, so thank you for watching. Don't forget to subscribe, share, and like my video. Bye.